We're gonna go through 6.2 and 6.3. Let me first maybe talk about the methods, right? We have the disk method. What is happening on the disk method? For the disk method, the following is going on. If we are talking about the rotation, about say maybe x-axis, the volume is defined by integral from a to b of pi rx squared dx. That is basically what is going on whenever we have something like that. What about when we are rotating about the y-axis? When you're rotating about the y-axis now, your volume will be defined from c to d pi ry squared dy. So observe that for this technique, whenever you are rotating about x-axis, you integrate in terms of variable x. And when you are rotating about y-axis, you integrate about variable y. And this is the formula. So if we will look at something like that, so here you see that they gave you the line y equals to x plus 1, y equals to 0, x equals to 0, x equals to 2 about x-axis, right? So let's see basically why is it applicable for us to use the disk method for this question. So if we were to sketch this function, you would have something like this. The line y equals to x, it intercepts at 1, and it also intercepts at minus 1. So I need something more or less like this. So it will intercept here and there. Say here it's minus 1 and there it's 1. Then you draw a straight line like that. Then we need our line y equals to 0. So that line will be here. This is the line y equals to 0. Then we also need the line x equals to 0. That will be here. This is the line x equals to 0. Then we also need the line what you call x equals to 2. Where is x equals to? Here. Right? So that will be a vertical line like this. When x is 0, y is 1, y is 0, x is minus 1. Then I have this. Then I'll have that line here. So you can see that really now, the region that we are looking at is basically this one. This is the region that we are looking at. Okay. Where the blue line, the red line, the orange, and the graph itself are bounding a certain region. So this is the region that is bounded by that guy. So what is happening with this blue region? If we are going to rotate it about the x-axis, if we rotate this thing about the x-axis, we go like this. Okay. observe that now what will happen here is that this region, right, it will not leave any space. There is no gap in between. If you had maybe something like this, a region that goes like this, for this one there will be a gap there. This is the gap that I'm talking about. Say we are looking at this region, there is a gap right there. However, between the axis of rotation and the bounded region here, the axis of rotation is x-axis, and this region, there is no gap. That means whenever you rotate this guy, whatever surface that you are going to get, okay, is going to be a closed surface. So if it's closed, there is no opening in at any point, then you're going to apply the disk method. Okay, so in this particular example, we are going about the x-axis. So it tells us that now really we need to use this formula. So our volume will be defined by integral from a to b. So you see that this point here is where we have 0 right there. So we'll integrate from 0 to 2 of pi. What is Rx? Rx is a function that we are dealing with here. Y equals to x plus 1. So we'll have x plus 1. That is our R of x raised to the power 2 dx. Okay, so then your volume now will be equals to pi integral from 0 to 2. If you expand this, you'll get x squared plus 2x plus 1 dx. So now the integral of x squared will give you that you have, we'll put the pi there. So we'll have 1 all over 3 x to the power 3. The integral of this one will give you x squared. And the integral of this one will give you x. And you need to evaluate this from 0 to 2. Okay. Maybe another thing that I didn't make mention of. Since we are rotating about the x-axis, we need to take the corresponding x values. That's why my a I take 0 there, and my b I take 2. I can't take the values on the y-axis. We are not rotating about that line. Okay, for the disk method, that is what is going on. So now we are going to get the result to be pi into, if we plug 2 here, we'll have 8 over 3. If we plug 2 here, we'll have 4, then plus 2. If we plug 0, everything will be 0. Okay, then we'll have that we have pi into, this gives us 6, and 6 times 3 is 18. So we'll have 8 plus 18 over 3. So what is 8 plus 18? That is going to give us 26 pi over 3. So that is going to be the solution of this problem. The volume is 26 pi over 3. Did you guys understand the explanation? Did you hear what I said? Like why I'm using this method and stuff like that? I need an answer. Yes. I cannot go back and forth into the meeting. We're gonna waste a lot of time. You can just open your mic and tell me, yes, I understand. Or no, say I didn't catch that. Can you please repeat? Is this one fine?
Yes, I understand.
Yes. Okay. If you don't understand, open your mic and tell me. I don't understand what we are doing. Can you re-explain? Then I'll do that. So now let's look at another one where we're gonna go basically say, maybe let me look at the one that we are going about the y-axis. if you're going about the y-axis, what is the idea? Okay, so we are given that x equals to 2 square root of y, x equals to 0 and y equals to 9. So we need to find the region that is bounded by all of this and rotate that region about the y-axis. Okay, so if we think about it more open-minded, you can see that really now what is going on here, this function is going to look something like this. Mm. It's going to look something like that, right? Or if you don't really see, or you don't know how to sketch when you have square root of y like that, you can basically say divide by 2 both sides, then you will get that 1 all over 2x equals to y. I mean square root of y. Then when you square both sides, you'll get that y equals to 1 all over 4x squared. So you can see basically you need a parabola that goes like this. So that is why I just drew that portion there. Because here for the square root of y, if I'm looking at it for the square root of y, it's only going to be where x is greater, where y is greater or equals to 0. Okay. So then now, that is what we have for this one. Now let's go ahead and draw where x equals to 0. X equals to 0 on this axis here. And y equals to 9. Say maybe 9 is somewhere there. This is where we have 9, somewhere here. Then I'm going to draw a horizontal line that goes like that. I mean, it goes on and on like that, but I'm not really interested in that. Yeah, so I'm going to draw it there. So the area that is enclosed by the green, the blue line, and the red line is this one. So this is the region that is enclosed by that, by those curves. And I want to rotate about the y-axis. So can you see again now, if I'm rotating about the y-axis, this is my y-axis. I'm gonna rotate like that. Can you see that this surface, it does not have any gap between the axis of rotation. So there is no gap between y-axis and the region. If there is no anything like that, apply the disk method. So we know the formula for the disk method whenever we're going about the y-axis is given by the volume, where we're integrating from c to d of pi ry squared dy. Okay, so r of y in this case is this guy, 2 square root of y. So you need a function x equals to something. That is your r of y. Okay, so we see that x equals to 2 square root of y. So now what is the bounds? Since we are going about the y-axis, we're going to take the bound. It's going from 0 to 9. So that is going to be our integral. We are going to say, okay, now the volume will be integral from 0 to 9 of pi. What is r of y? R of y is 2 square root of y. Then we square this, dy. Is that fine? Do you guys agree with me that this is what we're gonna get? More or less. Ne?
Yes.
Okay, so then now we can see that the volume will basically be integral. So we'll say pi integral from 0 to 9. If we square this guy, we're gonna get 4y dy. So that is what we're going to have. Then now, I mean, if we integrate, we get pi into what are we gonna get here? Hey, I put pi here. This is supposed to be 9. Sorry about that. So we'll have half y squared, then the half times 4 will give us the 2y squared. Then we evaluate this from 0 to 9. So basically we find the volume to be, if you plug 9 here, 9 squared. What is 9 squared?
81.
Then multiply that by 2. So you get 1625. So that is what we're going to get. Okay. Fine. Did you guys understand the analysis of what is going on? So really now, that is what we get for all of these functions from 11 to 16. All of them, you're going to solve them by the disk method. Because you will see if you draw all of the things that they gave you and you shade the bounded region, you will see that there is no space between the axis of rotation and the region. Then the disk method is applicable for that. Okay. However, now if we look at this one, for example, this one. Okay. What is going to happen if we have something like that? Just give me a moment. I want to go get some water. I'll be back. So what do we have now? Allow me to put this guy on the side there. Okay. So I'm going to sketch the function y equals to x squared. It's going to look something more or less something like that. Yeah. Sorry. Then the other one, y equals to 2x. I mean, you can draw something like that. Now, where do we have the area that is bounded by those two curves? The area is this one. Okay, you look at that area. Then you say, fine, now where do you rotate? You want to rotate about the y-axis. Of course, this is the line y equals to 2x, and this one is the line y equals to x squared. So then now, observe that between this region and the axis of rotation, there is a space there. There is a gap there. The region that I'm shading in yellow. This is the gap that I'm talking about now. Let me use a black color for that. There is a gap, or you can say there is a space in between. So this gap tells you that after you have made a full revolution, the solid that you're going to have will have a hole in it. So now if we use the disk method, we are going to calculate the volume in a sense that we also account for this yellow region. But then now there comes an idea of saying, okay, how are we going to then get rid of the fact that, or of the volume that is not supposed to be part of the region that is enclosed by those two curves? Okay, so that is when they start talking about the washer method. So you use the washer method whenever there is a gap between your axis of rotation and the region that is bounded. Okay, I'm gonna repeat that. You sketch the curves like we see them right there. We see that the enclosed region is this one where we have the red and the blue thing. where I shaded in blue. Okay, obviously this part is not supposed to be there, but you get the idea. Then now I'm like, the question that I ask myself, is there space between the axis of rotation and this region? Yes, there is a space. This is the space that I'm talking about, this yellow one. So if there is a gap right there, it tells me that now whenever I'm going to rotate this region, if I'm going to rotate this region, there will be a surface, right, that is going to be formed. That surface now is going to have a volume. But then the volume of that surface will also account for this gap that is there. So how do we get rid of that? So we need to subtract something from the volume that we are talking about. Initially, we had this when we were dealing about the disk method. We said we have integral from 0 to b of pi r of x squared dx. This is when we're doing the disk method. So now on the washer method, since you want to subtract this area, we say, okay, let's be open-minded about it. Okay, we have this and that. So this is this blue region that is there. If I make a full rotation, I can see that basically I'll end up having something like that. And yeah, I could have drawn a better sketch, but you know what I mean. Something more or less like this. So now I want to get rid of this area. Or yeah, whatever that is. But then that area, you can see that it is basically going to be an area that is formed by, let me use a different color, is going to be formed by the inner function. The circles that are going to be there will be formed by the inner function. The inner function in this case is our line, y equals to 2x. You can see there. This is the line, y equals to 2x. Even here, the negative of that. You say, okay, in that case then, we can see basically that the radius of those circles will change in respect to where we are on the function y equals to 2x. So we say this technique, we're gonna call it the washer method. Okay, on the disk method we only had this, but this give us the entire volume. So that means we need to account for the inner radius that is there. So we will say now the volume will be defined by integral from a to b of times pi of r of x squared, then minus small r of x squared dx, where we are going about the x-axis here, where r of x is the outer radius. By the outer radius, I'm talking about the radius that is going to be formed by this guy. This function is gonna form a circle like that as well. And the inner function will form a circle like this one. Okay, and my axis of revolution, of course, in this case is the y-axis. So can you see that this function y equals to x squared is the one that is going to form the big circle? So this is the outer radius I'm talking about. Okay, the outer radius. Then the inner one is formed by the line y equals to 2x. For this small green circle that I drew there is touching the function y equals to 2x from here to there. Okay, so the radius of that will be from here to the center, to the axis of revolution. That will be your small r of x. Or maybe let me write it there. That will be your small r of x. And the black one will give us a radius from here to the center as well. And that will be your big R of x. And is defined by the function. Since we are on the x-axis, on the y-axis right there for this problem, we don't really I'm saying, okay, let me stop using this example. because here I wrote the function in terms of x. It will confuse you. When we're going about the y-axis, we'll use the functions here, r of x, r of y. It's fine. So your outer r of x is the outer radius, and small r of x is the inner radius. That is what we're gonna have. Okay. Then what about when we are going when we are rotating about y-axis? When we're rotating about the y-axis, it's gonna be the same fate. That now the volume will be integral from c to d pi into r of y squared minus small r of y squared dy. Where of course still r of y is the outer radius and small r of y is the inner radius. Okay. So in our question now, we're gonna utilize which formula? We're gonna utilize this one because we are rotating about the y-axis. Okay. So does that explanation make sense to you now? More or less, I don't know.
Yes.
Okay. So then now, for this problem, what are we gonna have? Which one is going to form the outer radius? It's gonna be this one. So we need to use the formula v equals to integral from c to d of pi into r of y squared minus r of small r of y squared dy, like that. So this blue line, the line y equals to x squared, is gonna form our is gonna form what? Our outer radius, right? So we need r of y, and we have here y equals to x squared. So that means x equals to square root of y. So our r of y, big R of y, is then square root of y. Then for the inner one is formed by this line, y equals to 2x. So we have y equals to 2x. So that means x equals to 1 all over 2y. And this implies our small r of y is going to just be 1 over 2y. So this is our small r of y, and that is our big R of y. Then we substitute the things. Can we? Yes. The other thing that we will need is the bounds. Okay, since we are going about what you call the y-axis, we're gonna need the values of y. We're gonna need the value here from the intercept and the value there. The value there is gonna be 0. Then the other value here, how are you going to find that? To find that, at the intercept, these two equations are the same. So you'll basically have that x squared equals to 2x. Then x squared minus 2x equals to 0. You factor out x, you have x minus 2 equals to 0. Then you get that basically x equals to 0 and x equals to 2. So x is 2 here. When x is 2, what is y? Take this x value, substitute it into one of the two equations, either this one or that one. It will give you the same thing. So if you substitute it in here, you can see that for x equals to 2, we get that y equals to 4. So the value here is 4. So this integral now is going to be volume is going to be defined by integral from 0 to 4. You're going from 0 to 4 of pi into, I don't know, what is r of y? The big R of y is square root of y. So you'll have square root y raised to the power 2 minus small r of y is 1 over 2 y raised to the power 2. Then dy. Is that fine? Do you guys agree this is what we have?
I'm confused.
You are confused.
Yes,
Okay.
because I don't understand why the outer radius is square root y.
The outer radius. This one. Okay, let's first talk about this.
So before you answer,
Hmm?
I'm saying before you answer, uh,
Yes.
you will always have to draw it, be able to draw the graphs because sometimes other equations are tricky.
I'd say it's safe for you to be able to sketch those functions. At most, know the mother graphs, like the line, the line y equals to x. Then from there, the transformation, if they do the transformation, it's easier for you to know where it's located. Then mother graph y equals to square root of x, e to the x, sine x, cos x. Those are the mother graphs that you should know of by heart. Then if there is a translation or transformation of the graph, then you can take it from there. So
Okay, thank
yeah,
you.
it's gonna be important. What is not really important for you to draw is this sketches. This one. Okay. So um to answer or to clarify for you, Dudley, why we say r of y is square root of y. Think about this. Whenever we say you have a function y equals to x plus y. This function, they will say this is a function of x. Okay? Why is it a function of x? The independent variable is x right there. Right? However, if we rewrite this guy and say we take 1 to that side, we'll have that x equals to y minus 1. So since this side it will only be y that is the independent variable or that is showing there, we can say this is f of y. So whenever we make x subject of the formula, we get the function in terms of y. So we call it f of y. Similarly, here, whenever we make y subject of the formula, we get f of x. I think that you are familiar with, specifically for this one.
Yes.
Okay, so that is what we desire. So in our case, we need r of y. So that means we need to make x subject of the formula. If we make x subject of the formula, we get y equals to, we get x equals to y minus 1. Then we call that f of y is y minus 1. Now, in our case, since we are revolving about the y-axis, we're gonna use this formula. You understand that we need to use this one?
Yes.
Fine. This formula comes with r of y, big R of y and a small r of y. So now, we know that this one is the outer radius. Okay, is formed by the outer function. If we look at these two, we have a line like this, and we have a curve y equals to x squared. Which ones between this function and that one is the most outer one? This one. The line y equals to x squared. So this one, that is why we say that is going to form an what you call, is gonna form the outer radius. If we rotate this thing about there, say this is the y-axis. If we rotate it, we make a full revolution about that line. Then this one will be that one. Then we'll have this. More or less something like that. Now let's make the traces. Okay. If we make the traces, I'm gonna remove that top circle for now. Drawing these things is a job and a half. We know the top circle is gonna be something like that, right? Let's remove it for now and see which one is going to give us a bigger circle. If we start a circle from this function, this one, y equals to x squared, which is also this side, the negative part of it. After we have made a full revolution, it's gonna look something like that. So you start from this function to that. Okay, draw a circle. If we draw a circle, we'll have something like that. So we will have that big red circle right there. Now, for the line y equals to 2x is this green one right there. So I'm gonna draw a circle again from this point to that point. You see this, before revolution it was here. Now I made a full revolution. Obviously I'm just looking at the front side of that, or at one side of that thing. I'm not drawing it in 3D. Then the other side is this one. If I draw a circle in there, I'm gonna have something like this. So between this blue circle and the red circle that we have, can you see that this one is the bigger one, is the one that will have an outer radius? If our center is there, it's gonna give us an outer radius, which is formed by y equals to x squared. And the blue one now is going to give us, from the center to the blue, we're gonna get the inner radius of the thing. Do you agree?
Oh, okay. Yes, I understand now.
You see that now?
Yes, thank you.
Sharp. So that is how it goes about. So like maybe, yeah, you'll see as I do more examples. So you can check if ever you truly understood from this one. Okay, thank you. So then now here we're gonna have the following then, that the volume is defined by integral from 0 to 4. Then you have pi into, this will be y. Then this one will give us minus 1 all over 4 y to the power 2 dy. That is what we're gonna get, right? Then, yeah, I don't know. From here, what can we say? We just need to integrate. There is nothing fancy about this guy anymore. Can we integrate that? If we integrate, we'll get pi into, the integral of this guy will be 1 all over 2 y squared. And the integral of this guy will be 1 all over 3. You multiply it with 1 over 4, you get minus 1 all over 12 y to the power 3. And you evaluate this from 0 to 4. Then the volume will be pi into 1 all over 2 times 4 raised to the power 2 minus 1 all over 12 times 4 raised to the power 3. And if you plug 0, everything will be 0 right there. So this is what we're going to have. So the volume will therefore be pi into, what is 4 to the power 2 is 16. Divided by 2, you have 8. Then minus, what is what you call 4 to the power 3, I can write that as 4 times 4 squared. Then I know here I'll have 1 over 3 times 60, right? Yeah, 3 doesn't go in 16. That's 3, 6, 9, 12, 15. No, it does not. So I rewrote this guy as 4 times 4 squared. I mean, if you know what is 4 to the power 3 right away, you can do that. Okay, but I see this is multiplied by 1 over 12. This 1 over 12 that is there. So I wrote 1 over 21, sorry. So I know that 4 over 12 will give me 4 goes how many times in itself? Once. And in 12 it goes 3 times. Then that is 4 squared is 60. So that is how I got that result. Now what is 8 by 3? 8 times 3 is 24. I'm going to multiply this guy by 3 over 3 because I want it to have the same denominator as that one. So therefore my volume will be defined by pi into 24 minus 16 over 3. Then we get what? What is 24 minus 16? We get 8 over 3 pi. So that is the volume that we get from the thing. Okay. Then again, we come to this one. So we have y equals to 6 minus x squared. Yeah, y equals to 2, and you want to rotate that about the x-axis. If you think about this function, it's a function of y equals to minus x squared shifted 6 units up. So you will have something like this, where here you have 6. Okay. Then they say we also need to sketch the line y equals to 2. Say the line y equals to 2 is somewhere here. This is the line y equals to 2. And you want to rotate this by the x-axis. What is the region that is bounded really here? The region that is bounded is this one. Can you see that now? Between the region and the axis of symmetry, there is a gap. In fact, I don't need to sketch to draw the whole thing like that. Let me just do it here. Right there, we have a gap. What do we do whenever we have a gap? Washer method. Where are we going about? X-axis. So the volume is defined by integral from a to b of pi into r of x squared minus r small r of x squared dx. I know I need to use this method before interpreting what is a, what is b, what is r of x, big R of x, small r of x. I already know which technique to use. Then now I go to ask myself, what is going to be r of x, and what is going to be small r of x, and obviously what is a and what is b, the bounds, that is. Okay, so then now obviously for the bounds we're gonna need where we have the intersection of the line y equals to 2 and the curve y equals to 6 minus x squared. So we'll find that we have 6 minus x squared should be equals to 2, right? Then really now x squared will be equals to 6 minus 2. So x squared equals to 4. So x equals to plus minus 2. So that implies then now, what do we have there? Here, we have minus 2. Then here we have positive 2. So this is the region that we are going to integrate from minus 2 to 2. So I know in this case my a is minus 2, my b is 2. So then now the big question that therefore keeps lingering right there is, which one is going to be my r of x, big R of x, this one. Which one will form the outer radius? The top function, this one, is the one that is going to form the outer radius. Then the bottom one, which is the line y equals to 2, will form the inner radius. So if you think about it, you have the x-axis here, then you have something like this, okay, and you rotate this guy about the x-axis. If you rotate that guy about the x-axis, you'll get a line, which is this one. Then you'll get that curve going like that. So can you see that now? If you draw a circle from this curve, y equals to 6 minus x squared, you'll get something like this. And now if you draw a circle from here and there, you'll get something like that. So this red one gives you a smaller radius, r of x, and the bigger one gives you the big R of x. Then you are done. So then you know your big R of x is defined by 6 minus x squared. And your small r of x is just going to be defined by 2. The line y equals to 2, so it's just 2. So therefore, you say now your volume is integral from minus 2 to 2 of pi into 6 minus x squared raised to the power 2 minus 2 raised to the power 2 dx. So the volume then is defined by the integral from minus 2 to 2 of pi into, what is this guy? 6 squared is 36, is it? Yes. Then we'll have 36 minus 12x squared plus x to the power 4. Then this guy will give us minus 4 dx. Then 36 minus 4 will end up having integral from minus 2 to 2 of pi into x to the 4 minus 12x squared, then plus 32 dx. So now we'll say, let's integrate, because really now, yeah, we can integrate this function that is there. So we'll have the volume, we'll have equals to pi into the integral of this guy, 1 over 5 x to the power 5, minus the integral of this guy will give us 1 over 3 x to the power 3. Then 12 divided by 3, that is going to be 36 minus 12, it's 4 x raised to the power 3. Then this guy will give us 32x. Then you evaluate this from minus 2 to 2. Okay. If you are smart to remember the technique, whenever you are going from minus a to a, you can realize that this is the same as 2 times the volume is 2 times pi into 1 all over 5 x to the 5 minus 4x to the power 3 plus 32x, where you evaluate this now from 0 to 2. If you don't remember something like this, it's fine. There is no problem with that. Evaluate it with from minus 2 to 2. You shall get the same solution. But, I mean, if you're going from minus a to a, it's just 2 times that thing from 0 to 2. Okay? Only if it's from integral from minus a to a of f of x is the same as 2 times integral from 0 to a of f of x dx. So you see, if you are going from in this case from -2 to 2, our a is 2. Then we can say 2 times whatever that we get. But if you have this from, I don't know, -1 to 3, you cannot apply this because the a are not the same. Here we have a is -1, I mean a is 1, but then there you have a different value from that. You cannot use that technique, okay? So yeah, I want to use this because I'm avoiding to substitute 2 then go substitute -2. It's gonna be a long thing. Okay, since I'm racing against time, I become smart about it. I use the trick. Then I say now the volume will just be 2 pi into, if I plug 2 here, what is 2 to the power 5? I don't know, that is something like 32 over 5, then -4 times 8, then plus 32 times 2, that is going to give me 64. Okay, then you can put this on a calculator and see what you get. I mean, or you can do it from the top of your head. Like, yeah, I don't want to waste time on these numbers. I guess you guys are not interested in the numbers. So you can do that and find out what is your final answer right there. So if I was to do that with you, I'll say -4 into 8, then plus 64. And this answer times 2. So your final answer should be something like this: 384 over 5 pi. You see, it's a very big number. That is crazy. But yeah, in any ways, you can get something like that. As you should verify. Okay. Any questions? I'm taking it slow so you guys can understand what is going on. So if you feel like maybe I'm moving too slow, yeah, I'm doing that on purpose because, yeah, I want you to get why we are doing stuff. Seems from the previous lessons you all were not following with what was going on. Do you guys now understand? Oh, the meeting just dropped us like that. Okay. Masubele 16 days no sleep. Okay, push on way. Left the box really sharp. Okay, guys, so long does it make sense what we were doing? And can you differentiate now between the washer method and the disk method? Like where to apply it in a sense. Where, when, yeah.
Yes.
Does that go for everyone? I just got one response. I don't know.
Yes.
Okay. So it's gonna be 19 is gonna be the similar idea as 17. I mean, but just be careful with the rotation. Here we were rotating about y-axis. Here we're gonna rotate about the x-axis. Okay. So pretty much, what we've been doing, these functions from thereafter from 18 to 20, they will need the same application. The only thing that will make something different that we have not yet discussed is this one, because now our center is shifted, or can I say the axis of rotation is shifted from the x-axis to the line y equals to 1. So what are we gonna do? That will affect your r, outer radius and inner radius, your big R of x and small r of x. They will be affected by this. How? Let's see that.
I cannot see the screen.
Oh, don't see the screen. I technically forgot to share. Thank you for letting me know that. So I was saying that, like, The question is now from 17 to 20 under 6.2, right? They will follow the same idea that we did on this one and that one. Okay, you will see there will be a gap and things like that. However, there is something extra that we need to talk about that will come when now we have shifted the axis of revolution. Now we're going to revolve around the line y equals to 1. We have shifted from the x-axis to the line y equals to 1. So the line y equals to 1 now is going to be the center. So if the center has shifted, can you see that basically now our radius is going to get affected, our big R of x and small r of x. Let's see how that will unfold thereafter. You're still gonna do the washer method, but be careful of what you call the axis of revolution. Okay, so what do we have there? If we sketch that, we have the curve y equals to x squared. You can say it looks something more or less like this. Okay, let me make it touch the origin. Yeah, I want to make it bigger. Yeah. And the line, not the line, but rather the curve x equals to y squared. And that one I can say it's a curve that goes somewhat above this. And we all can see that basically now the region that we are at. Can you guys see the screen?
Yes.
Okay. So the region that we are at now is this one. Please accept that person for me into the meeting. Thank you. So this is the region that we are looking at. Okay. That is enclosed by the black and the red curve. Fine. So then now, where are we revolving? We're revolving about the line y equals to 1. I'm not saying where that is, whether that is here. Oh my, wait. Damn, I did back by mistake. Come on. Okay. So I will need to first find the intersections before I can draw this line. Because I could assume it's here, but it's not there. Because remember, I'm not drawing the things to scale, okay? So I need to be careful with that. So let's first find what is this point here and what is the point there. So we can know whether the line will be below this point or it will be above this point or it will be exactly at that point. Those are the three possibilities. So what are we going to have? We'll have that y equals to x squared and x equals to y squared. So we have y equals to x squared. Then this one tells us that x equals to y squared. So we can substitute y squared in the place of x here. Then we'll get that y equals to y to the power 4. Then if you take y that side, we'll have y to the power 4 minus y equals to 0. Then y into y to the power 3 minus 1 equals to 0. Then we get that y equals to 0 or y equals to 1 from this guy, y cubed equals to, y cubed minus 1 equals to 0. I take y that one that side and take the cube root of that. So I get this. So I know this is 0 and this here is 1. Okay. So yeah, that is what I'm going to have. Now what is the corresponding x value? The corresponding x value, plug y is 1. Or in fact, you can plug it in this one. If you plug y is 1, x will be 1 as well. So then now draw the line y equals to 1. So that line will be exactly passing at the line or at the point of intersection. So this is the line y equals to 1. And we are going to rotate about this line. Okay. So what is it going to be now? If we're rotating about this line, obviously we need to use the washer method, right? The axis of revolution or the line of rotation is this one, and the surface is that one. Do we have a gap between these two things? Yes, the gap that I'm talking about is this one. So we have that gap. So this gap tells us that we need to use the washer method. Okay, so if I know I'm gonna need to use the washer method, I have v equals to integral from a to b, and I'm rotating about the line y equals to 1. Think about it. When this is a horizontal line, so when you are rotating about a horizontal line, you are going to have that the volume is in terms of variable x. So you'll have integral from a to b of pi into r of x squared minus small r of x squared dx. And if you were doing the rotation now about the vertical line, it will be integral from the volume will be defined by the integral from a to b of pi into, now you'll integrate in terms of y, small r of y squared dy. Okay, so when you are rotating about the vertical line, say a vertical line x equals to 1 or something like that. So this, you're gonna use this formula. You're integrating in terms of y. Just understand that or remember that, so you don't end up being confused which formula to use. Okay, so now the big question comes. What is r of x? Big R of x. Big R of x, what is it gonna be? Let's first do the following. From these functions, let's make sure that for all of them, y is the subject of the formula. So we have y equals to x squared. This one is fine. And from this one, we have x equals to y squared. That means if we make y subject of the formula, we have y equals to square root of x. Okay. Remember that on the caps, this black one was y equals to, it was x equals to y squared. And the red one, this is y equals to x squared. Fine. Now, if we are going this way, we are going to rotate this way. Which one is going to, give us the outer radius? Is this red one? This one. This one will be the inner one. This one will give us the outer one. Think about it. We have something like this. Then something like that. And we have the axis of revolution. If we rotate like that. Okay, this function is going to come to the top like this red one, after a full revolution, and the blue one will still be inside like this. So then again, if you were to draw a circle from the red function, you can see that it's going to give you a bigger circle as compared to when you draw the circle from this blue function. Hence, this red one will give us the big R of x, and the blue one, or the line, the curve x equals to y squared, will give us a small r of x. But we need to be careful, because this axis of revolution now, what is it? Is the line y equals to 1. Okay, so if that is the line y equals to 1, observe that now the radius of this one, this is going to be our center. The line y equals to 1 is going to be our center. The radius now is going to go from the circle to there. Okay, so I'm going to put a picture here and ask you a question for distance. If you have, let me say, m and n here, and I ask you what is the distance between m and n, the distance between this will be what is at the top minus what is at the bottom. So in particular, if I was using numbers and I say here I have 2 and here I have 1, what is the distance between 1 and 2? We'll say 2 minus 1. You see the top one minus the bottom one. So now here I have the line y equals to 1. So this is 1, and this here is the function, the red function. Which function? This one, x equals to y squared, which we rewrote and said is the same as y equals to square root of x. So now, if this one is at the top and this one is at the bottom, that means r of x will be 1 minus square root of x. Okay, then what about the small r of x? The small r of x is at the bottom as well. Then the line y equals to 1 is at the top. So there, that one will be 1 minus what is the function? X squared. Wait. I swapped them. It's not supposed to be this. It's supposed to be the other way around. I swapped the functions. Did I? But the red one is x squared, sorry. So this is supposed to be x squared. Then this one will be 1 minus square root of x. Do you guys follow? That is the only new concept that we are putting on top of the information that we know. It's highly likely they will ask something about the line, the revolution about the line. So you need to understand what I'm doing now. Did that go for everyone? Lovers, is it fine?
Os mineros com as clínicas de digesta.
You mean I did what? My question is if ever you understand how we got this and that.
Oh yes, I'm good, sir.
Okay. Mtlongo.
Yes, I understand.
So then now we have completed our analysis more or less. So if we, like I said about the horizontal line, this is a horizontal line. y equals to 1. So we are going to integrate in terms of x. That means we need the values of x. We'll take 0 and 1. Those are going to be our bounds. So therefore, our volume will be integral from 0 to 1 of what? Hmm? Pi into 1 minus 1 minus x squared raised to the power 2 minus, substitute there, 1 minus square root of x raised to the power 2 dx. Then you can simplify this guy, multiply out, and similarly with that one, then find out the integral, substitute 0 and 1. Then you can get the volume. My interest is if you can get this, if you can get that. If you understand that plugging into the formula is simplifying, that is not a new thing for you. So I think everybody's fine. You can continue from there, right? Yeah, I'm going to move on. So 22 is the same analysis. You see, we are still revolving about a horizontal line, y equals to minus 3. Similarly with 23. Similarly with 24. Now 25. No. I need to say something in regards to this one. Because you see here, the line, we have y equals to 1. It was on the positive y-axis. This one is going to be on the negative side. So maybe let's look at something like that so you can be able to know what to do there. The analysis is more or less the same thing, but then I think it's good that we go through the idea together. Okay, so we need to sketch y equals to x to the power 3. So you can say it's a function that goes like that. More or less something like that. Then the line y equals to 1, say 1 is somewhere here. Maybe let me put it there. The line x equals to 2. So when x, so here you have to be careful. Okay. In fact, I'm gonna need this line to go a little bit lower. You have to be careful because when x is 2, you need to know what is y. So if x is 2, plug it in here, you will get that y is 8. So you can see that the point is here. So you need to put that line. Just as my graph is not gonna give something nice. I'm gonna try to draw a better sketch for this guy. So say the line y equals to 1 is here, then we have that. And if x is 2, we need to know what is gonna be y. Say 8 is somewhere there. Then we'll have this point here. Then draw that line. The reason I needed a better sketch is because you can see the region that is enclosed is this one, and it's so small. But yeah, I think you guys get the idea. I'm gonna try one last time, but if it doesn't allow me to draw nice stuff. I mean, I'm bad with drawings in any ways. So I'm just gonna put it here, that line. Let me start with it and say the line y equals to 1 is somewhere there, just so you can see the region. So the region is gonna be this one. So I know here this is 8 there, and this is 1, and this right here is 2. Then of course we need to revolve that about the line y equals to minus 3. So the line y equals to minus 3, say minus 3 somewhere here. So I can put it right there. This is where we need to revolve now. So can you see now that there is a gap between our bounded area and what you call the axis of revolution? So this tells you washer method. So you have a gap right there. This implies you need to use the washer. Okay, fine. Since you are going about the horizontal line, what is the volume? The volume will be defined by integral from a to b of pi into r of x minus r of a small r of x squared, sorry, dx, like that. Then what? Then let's do the analysis. I need to know, since I see that I'm going to integrate in terms of x, I need to know what is the x value there. The x value here, I know it is 2. That is fine. What is going to be the x value there? That x value, you're going to find it because you know this line is the line y equals to 1. So when y is 1, you plug it here, you get that x to the power 3 equals to 1. So this implies x is also 1. So you have 1. So we'll be integrating this from 1 to 2. Now I need to know what is my r of x and what is my small r of x. So looking at this region, which one is going to form the outer radius and which one is going to form the inner radius? So the top one, which is the function y equals to x cubed, is going to form the outer radius, and the bottom one, this line, y equals to 1, will form the inner radius. Okay, so you will have now what is going to be the distance from let me use a green color, from this function to the center. Can you see now the roles have reversed now? We are going to have the function is at the top. If you remember the analysis I showed you earlier of m and n, and if I want to find this distance, I say m minus n. So in this case, our m is the function x raised to the power 3. Then we need to subtract n, where n is minus 3. So it will be minus 3. So in particular, we have x cubed plus 3. What about for this line? If we go from here, the line y equals to 1, to the center, we can see that now we'll have 1 minus 3. So this gives us 1 plus 3, which is 4. Okay, so then you plug it into the formula, you will have the following: x cubed plus 3 to the power 2 minus 4 to the power 2 dx. Then you expand you find the volume. Did you guys understand this? Everybody?
Yes.
Yeah. So that is what is gonna go on. Okay. So if you understand that now, it will follow the same idea for this one. You can see you have the line y equals to minus 1 right there. So it's at the bottom. I mean at the negative side of the y-axis, that is. Then now we can look at something like this one, where we are rotating about a vertical line, x equals to 2. And also look at when we are rotating about a vertical line, where now we are on the negative side of the x-axis. Then once you understand all of those things now, you have mastered Washer method. There is nothing more they can add into the equation that will make your life complicated. So let's do it together. If we sketch that function, y equals to x cubed. Yeah, this function is giving me problems when I need to sketch it. This time around, I hope I'll get it right at one go. Then y equals to 0. This line is sitting here, exactly on the x-axis. We know this is the line y equals to 0, and the line x equals to 1. So if suppose 1 is there, then we can draw that line. Okay. Then we can see that the region that we are looking at is this one. This is the region bounded. Okay. So then now draw the axis of revolution. The axis of revolution is going to be the vertical line, x equals to 2. So say 2 is somewhere there, then you have a line that goes like that. Okay, all right. So then here obviously is 0. Then this is the line x equals to 2. Now, what is the big question? The big question comes from the idea that what you call, if you are rotating about the vertical line, which form we like to use? The volume is going to be defined by integral from a to b, pi into, when you're using the Washer method, is going to be r of x squared minus small r of x squared. I said x, no, it's supposed to be y, sorry. R of y squared minus small r of y squared dy. Okay, it's more or less like you are rotating here. When you are rotating here, you integrate in terms of y. Now they've shifted the center to be at x equals to 2. So you still integrate in terms of y. Okay, fine. Now let's go ahead and find out what is going to be this point. When x is 1, what is going to be the corresponding y value there? Because if we're integrating in terms of y, we cannot take this bound and that one. We need the bounds on the y-axis. So we're going to take the values from the y-axis. So now we know that when x is 1, you plug it in here, you're going to get that the corresponding y value is 1. So we're going to integrate from 0 to 1. Okay. Now, my question to you is, what is r of y? And what is small r of y? This one is going to be given by the one that will form the outer radius. The outer radius will be formed by this one, the line or the curve y equals to x cubed. If you revolve around this guy, the outer function. Okay, so you ask yourself, what is going to be the distance from the function to the center? This is going to be your center. So now, since we are looking at it this way, say the distance between m and n, in this case, what is it going to be? Is going to be n minus m. So you'll have n minus m. That is going to be your distance. Okay, so if you think about it, your m now is the function, and your n is the line x equals to 2. So your n is 2. So you need to have now, this is going to be 2 minus x, no, not x cubed. We need to first rewrite this guy. If we rewrite that guy in terms of y, we make y subject of the formula, we get that x is cube root of y. So we'll have 2 minus cube root of y, or y raised to the power 1 over 3. Okay. Then now, which one will form the inner radius? The inner radius will be formed by this one, this line. So you go from there to the center. So you can see that now you have 2 minus 1. The line here is x equals to 1. So we'll have 2 minus 1. So this will give you 2 minus 1. Is that fine? So basically this equals to 1. Is the explanation giving or indluyawa? Indluyawa, ne? Talk to me, guys. The r of y and r, small r of y.
It's making sense.
Okay, great. Then you go ahead and plug them here and see that basically you have 2 minus y raised to the power 1/3 raised to the power 2, then minus 1 squared, then dy. Obviously you need to do the things for this one, expand it, then find your volume. So that is how you're gonna do the thing. Okay, so then now, what if the thing was here, the axis of revolution, x equals to maybe say minus 1? We need something like that now. Okay, so if you think about it, what was it gonna be? Say, instead of the thing being here, instead of revolving about this line, we revolve about this line. What was going to be our r of y? And what was going to be our small r of y? One delay, what do you think will be the thing? Big r of y will be which one? If we are revolving about this line.
Sorry, what was the question?
My question is, if instead of revolving about this line x equals to 2, say we revolve about the line x equals to 1, what is going to be r of y and small r of y?
In terms of M and N,
No, no, no.
or or
For this, for the
the
same
graph.
functions that we have here.
So it was gonna be um R of Y, the big one. It's, you said, if It was about the y-axis.
No, the line x equals to -1.
Oh, it was gonna be 1 plus 1.
Ex- Yes. So it will be 1 plus 1. So for those who don't see where the plus came from, you say this is now you're going to say this one. Okay. Maybe let me use an orange thingy there. So now this line x equals to 1 is the one that is going to form the bigger radius. You can just check the lines. If you draw the line from here to there and draw another line from this function to that one. Okay. You can see basically that maybe let me put it somewhere here. And you draw from the function to there. You can see the shorter line tells you that it's going to be the inner radius. Then the longer line tells you that that one will form the bigger radius. If you don't want to draw the things like the surfaces, I think that is another analysis. This way maybe it's gonna be even way quicker for you to remember. Okay, so you can put on your note there. So okay, so here we have -1 at this point here. The center it's -1. So in terms of m and n, how she got that, we are gonna have 1 plus 1. What she did is that in this case, this is our m, -1 is our m, and this one is our n. So we'll have 1, according to this, 1 minus -1. So we'll have 1 minus -1. Then this will give us 1 plus 1. So in particular, this guy will be 2. Okay, that is correct. Thank you. Then what about small r of y? Yes, one delay.
It's x cubed plus 1.
X cubed plus 1. So how you get that is the same idea. You say x cubed minus -1. Then you get x cubed plus 1. Okay. So those are the things that I feel like if you understand them, then you will be fine. Hopefully. So such an example, if you want to test yourself, you can do 26. Because you can see we are revolving about the line x equals to -1. It's on the negative side, like this one. So it's going to follow the same idea. Any questions so far? There are no questions. So you guys are satisfied.
There are no questions from my side.
Yonela, the other time you asked me how to differentiate between which technique to use and so forth. So does this now clarify the things?
Yeah, yeah, I know.
Okay. So the last thing now is the shells method, where they're talking about the cylindrical shells. And obviously that is 6.3. Okay, I mean, you can practice more problems and stuff like that. Let me just check. I want to give you an exercise to go and do 28 on your own. I did this the other time in class. And if you do it on your own, if you understand, you should be able to comprehend what is going on there. Okay. So now we're gonna do this one, the cylindrical shells, the shell method. Maybe if you go read here. In fact, I don't want you to go read information. I'll give you the information. Because once you start reading, you'll start doing using formulas in the book. They are the same, but from how I gave them to you, they're already simplified. Okay. In the book, they like to use the area, what. So once you start talking about that, people get confused. It's better off if we write it out. Um, I want to see nice examples. Yeah, maybe these ones are nice examples. I describe the solid now. You're not gonna describe that. I mean, this is going back, reversing the area bounded from 0 to 3 uh, with radius x, and the function is y equals to x to the power 4. Ah, cannot fail to reverse something like that. The other interesting ones are these ones. These ones, why are they interesting? Is because now they say the region bounded by the given curves is rotated about a specific axis, then find the volume of the resulting solid by any method. So this is after you have mastered everything, come to do these exercises. Be able to comprehend, okay, if I have this, can I apply this method? Can I apply washer method? Can I apply cylindrical shells? You'll be knowing why you do that, okay? Then, yeah, it's easy stuff. So don't go there without doing problems 53 to 59. So now I'll start with the what you call the shells method. Or in the book they call it cylindrical shells.
See,
Shell method. Okay, so whenever we are using this technique, is when we encounter a problem like, say we are given a function y equals to x to the power 3 plus x plus 2. And we want to rotate about the y-axis. So if you want to rotate about the y-axis and you have this, we know that our desire at some point in time, when we were using the washer method and or the disk method, okay, we would want to say that, like, I don't know, what is the function f of, or let me use r since we are using r all along, r of y, what is that thing gonna be? And whenever you want to put r of y, that is when x is the subject of the formula. Can you make x subject of the formula from that function? The answer is no. But can you find the volume? The answer is yes. And what is the technique that you're going to use? Is the shells method. So then now it goes about what you call the following. Say if you are going to be rotating about the x-axis, okay, if you're rotating about the x-axis, you can say slash horizontal line. And what are you gonna have? The volume will be defined by integral from a to b of 2 pi r times f of y dy. Is that so? Wait, let me think about it. Yes, if you are rotating about the x-axis, you're going to integrate in terms of variable y. Okay. Now, if you are going to rotate, can you please turn off your mic for me there? Thank you. If you are going to rotate about y-axis, say slash vertical line, your integral now is going to be in terms of variable x. So you'll have integral from a to b, 2 pi r um, times f of x dx. Okay, so put nb, r will be equals to I don't know why. When what is happening? When are we gonna have r to be y? When rotating,
We're gonna have when you rotate about the x-axis.
yes, about the x-axis. Otherwise, it's going to change. If you are going to rotate about the horizontal line where they have shifted the axis, it's going to change as well, depending on which side are we at. Are we at the negative or the positive of the x-axis? But the idea is still the same. So if, say, you are here, you are revolving about this line, okay, then we know that here would say the function minus this one, and if whatever the line is there, and if we're here, would say the function or the region is somewhere here, then we'll say the function plus, I mean, sorry, whatever the line gives us plus, I mean, did I say plus? Minus the function, okay? So the same ideas that we were using earlier on. So here, your r will be x when rotating about y-axis. So that is what you're going to have. All right, without wasting time, we can get into the ideas and see exactly how we're going to utilize this technique. Let's start with ones where we are revolving about what you call about like 9 to 14 we are revolving about a specific axis, that is y-axis, and from 15 to 20 we'll be revolving about the x-axis. Okay, maybe I can do one from here and one from there. Then now about the horizontal lines. All right, so let's do that. In fact, let me do this one. Let me do 14. On my side, I see this thing is like writing and doing things after some time. Let me reload it so it doesn't keep persisting with whatever that is. Are you guys scared for Saturday? Hmm? You mustn't panic. There won't be something new that you see in there. Everything you'll see in that test will have gone through it. Not necessarily the same question, but the idea or the concept, you will be knowing what to do. So you must not rush. Okay, that is a bad advice. I don't know how to put the one of speed. Don't be too slow, don't be too quick, because you'll miss some things, okay? And avoid this thing of writing with a pencil, then write with a pen, erase the pencil. Can you see how that thing is taking a lot of your time? If you made a mistake, just scratch out, then write the thing. Don't want to be a paper that is neat. It's mathematics. They know mistakes are made. All right. Um. Okay. So if we want to sketch this function, we can look at what you call what are the intercepts and what is the turning point. Let's first find the turning point. If we derive this guy, we will find that we have 4 minus 2x. And at the turning point, this should be equals to 0. Then we basically see that 2x should be equals to 4. Then x should be equals to 1 all over 2. Okay. So when x is 1 all over 2, you plug it in here, we get the corresponding y will be 4 into 1 over 2 minus 1 over 2 raised to the power 2. So you basically get the corresponding y coordinate to be, I don't know, 4 over 2 is going to be 2, then minus 1 over 4. So in particular, we get that we have 8 minus 1 over 4. So this is 7 over 4. Okay, so that is 7 over 4. This is bigger one, right? But smaller 2. It's 1.75. How you can find out whether it's bigger 1 or smaller 2, you can rewrite this where you have 4 at the top there. Say 4 plus 3 divided by 4. Divide each number there by 4. You get 1 plus 3 over 4. And what is 3 over 4? 3 over 4 is 0.75. So yeah, you can find the number like that. This one. I mean, we don't. Not that you will need that in any ways, but yeah. Suppose we don't know what we need, like we are there doing your analysis. So our turning point will be at half and 7 over 4. Fine. Now, what are the intercepts? The intercept, um, the x-intercept. This is when we have 4x minus x squared equals 0. We factor out the x, you get 4 minus x squared equals to 0. Then we can see that x equals to 0. And what is the other one? The other one will be that x equals to plus minus 2. Okay. What about the y-intercept? The y-intercept will basically happen at y equals to 0. So this is sufficient information for you to sketch this function. So if you sketch that, obviously it's a parabola facing down. Yeah. So say half is somewhere here. If half is somewhere there, maybe 7 over 4 is somewhere there. Then it's going to make a 10 right there. Then we need the intercept, y-intercept, to be that. And Yeah, I'm done. Do you guys see that here I factor an x, but I still have an x squared because now I'm questioning the plus minus thing. So this is supposed to be at x equals to 4, not a plus minus 2. Okay, so yeah, it's gonna cross not to scale at 4 there. It's fine. Then we need to draw the line y equals to x. So that line will do something like this. Then we need to find out what is the x value and the corresponding y value for that thing whenever we are um, at the intersection. So at the intersection, these are going to be the same. 4x minus x squared equals to x. So we'll have 4x minus x squared equals x. You take this guy to the other side, or everything that side, you have x squared plus x minus 4x equals 0. Then in particular, you can see that we have x squared minus 3x is 0. Then we factor an x, we can see basically will remain with x minus 3 equals 0. So x equals to 0, the intersection point there. Then x equals to 3, the intersection point here, the corresponding x value of that. And to find the corresponding y value, you can plug it in any of the functions. Plug it in this one because it's easier to find it quick there. If you plug 3 there, you get y is 3 as well. Okay. Then, yeah, this is something like that. Then where is the region that is bounded? The region that is bounded is this one, by those two curves. Okay. And we are rotating about, let me see again, about the y-axis. So if we are rotating about the y-axis, we need our volume to be in terms of variable x. So we'll say that the volume, the volume is defined by integral from a to b of 2 pi r, I don't know, 2 pi r f of y, no, f of x dx. Yes, so this is what was going on. We're going to find our volume using this formula. Can you guys see the screen now? Okay, so yeah, what is going to be our r? Since we are rotating about the y-axis, what did I say? R is x when rotating about the y-axis. So this is going to be x. And what is our f of x? The f of x, in this case, you can't take this one or take that one. You need to take the difference between the one that is at the top minus the one that is at the bottom. So you are going to have 4x minus x squared. This is the top function. Then minus the bottom function is y equals to x, so minus x. So basically, you get that your f of x is going to be 3x minus x squared. Right? So what are we going to get? We'll have the volume from, what are the bounds? From 0 to 3. So integrating from 0 to 3, 2 pi, r is x, f of x is 3x minus x to the power 2, then dx. Observe that this formula does not have squares here. Don't square anything. So the volume will be given by 2 pi I don't know, integral from 0 to 3. Distribute this x in here, we'll have 3x squared minus x to the power 3 dx. Then basically we get that we have 2 pi into, now integrate this guy, we get x to the power 3. Integrate this guy, minus 1 all over 4 x to the power 4. Then you substitute the upper bound, you'll get that the volume is defined by 2 pi into 3 raised to 3 minus 1 all over 4, 3 raised to 4. If you plug 0, everything will be 0. So whatever that will give you, then you get your volume. Is that fine? There are no questions on that, right? Okay, let me not put it like that. That is a wrong way of asking. Are there any questions on what we did now? Okay, that is the thing. Since we are revolving about the y-axis, do you see that? Mm, we cannot, of course, the space between the thing, the the bounded region and the axis of revolution is this one. We see a gap there, and this implies we can use Washer method. But now, when we need to use Washer method, and we are having the function y equals to 4x minus x squared, we need to write this function where we make x subject of the formula, which is tedious. We have a problem of making x subject of the formula. Then this is when you can say, okay, fine, I can apply the cylindrical shell method. Okay, because with that you don't need to make x subject of the formula. You know, when you are going about the y-axis, you'll integrate in terms of x, and you're gonna need f of x, and this function will be satisfying that already. And of course, it goes without caution that you need to be careful that you take their difference in this case. Okay, so that is what was going on there. Which one can I do with you together so can explain other things? There is nothing more I can say about this actually, now that I think about it. Is there something that you still find not clear what you need to do? Eh? Can we end the session here? I'm writing tomorrow, good people. Talk with me so I can know what to decide. Let's do another example. Maybe an example where we are going about the x-axis. So I'm going to do this. Sketch the function. The line x equals to 0 is here. and the line y equals to 2, say it's somewhere there. So the region that is enclosed is this one. And we are rotating about the x-axis. Okay, so if we are rotating about the x-axis, we are going to find our volume defined by integral from a to b of 2 pi r times f of y dy, integrate in terms of y. Since we are at the x-axis, our r will be a y. Okay, then what is going to be f of y now? Okay, our f of y, observe that here we have y equals to square root of x. So that means we need a function where x is the subject. So we have x equals to y squared. So that is going to be our f of y. Okay, so then, really now, what are we going to then have from the things? We need this and that. So this point here is 0. What is the point here? The point here is 2. Remember, this is the line y equals to 2. So the point there is 2. So we'll be integrating from 0 to 2 of 2 pi. What is r? R is 1. What is f of y? Y squared dy. Then, yeah, this will just be, I don't know, integral from 0 to 2 of 2 pi y to the power 3 dy. And we'll basically have 2 pi over 4 y to the power 4 evaluated from 0 to 2. If you substitute 2, you'll get what? What is 2 to the power 4? Is 16, eh? Then you'll have 2 pi over 4 times 16. If you plug 0, the thing will go away. Then 16 over 4, that is 2. 2 times 2 pi, it gives you 4 pi. Yeah. 2 to the power 2 is 16. 16 over 4 is not 2, it's 4, ne? So you'll have 8 pi. So that is how you would do that one. Okay. Maybe this one was somewhat easy. If you want something that will challenge you, you can try doing it and see if ever you can comprehend that. Okay. So I did about y-axis and x-axis. Now what about we are at a line, like here, vertical line, x equals to 3. Okay. If you are at that line, I'm not going to do the whole thing. I'm just going to show you that the idea is still going to be more or less the same. So we have this function. And we need the line y equals to 8. And we need the line x equals to 0. The line x equals to 0, you can say it's here on the axis like that. So the region that we are looking at is this one. And we are going to rotate about the line. About the line x equals to 3. So if we are talking about the line x equals to 3, this is more or less we have shifted the center from the y-axis to x equals to 3. We are here now. So the idea is that whenever we are rotating about a vertical line, the volume is given by this, right? From A to B of 2 pi r f of x dx. That is what we are going to have right there. Now, the thing is no longer on the y-axis. That means r is not equals to y. We need to define r. That is the only thing that you need to be careful of. So what is going to be r in this case? Can anybody tell me what is r? I know I said r is not equals to, I said y. I think I said y by mistake. It's not just x, but it has to be something. What is it gonna be? Instead of it just being x, it will be 3 minus x. So when you're here, this is the center of the thing. And we know usually our radius will just take it as what you call as x. So we need to say 3 minus that x of the radius. Then we have this. So if we were this side, say about the line x equals to minus 4, then our radius was going to be x minus minus 4. So in particular, it was going to be x plus 4. So this idea, you can apply it here on question 26. Okay. And of course, our f of x, for question 25, our f of x will be x cubed. We are not going to change that. So the idea that you apply on 25 is exactly the same as the idea on 27. So on 27, what is going to be r? Without even sketching this function, you can tell me what is r. We are rotating about the line x equals to 1. So what is going to be r? 1 minus x. 1 minus x. What is going to be r for this one? R will be 5 minus x. Okay. So that is what you're going to have. What about this one? You are looking at a parabola like this. Okay. But you want to focus on where y is greater 0. So this region. And at the line x equals to 2. So if say 2 is here, then that line will be there. So since we are focusing on y equals to 0, the region that is going to be enclosed, you can see is basically going to be this one. Okay. So if I do it nicely there, that is the region. The region inside of this red curve that I drew there is the one that we are looking at. And we are revolving about the horizontal line y equals to 2. So if y is 2, what is going to be x? Y is 2. We plug it here. We get that x should be 8. So we'll have 8 and 2. I don't know, say, okay, maybe let's find out also what is y when x is 2. When x is 2, y is 1. So when y is 2, 2 can be somewhere there. So that line will be up there. It's not going to intersect with the region. So you need to revolve about that. So since we're revolving about the, what you call the vertical, no, horizontal line, we know our integral is going to be in terms of y. So we'll have integral from a to b of 2 pi r f of y dy. Now what is r? R is going to be what you call, I don't know, say 2 minus 2 minus y. That is going to be your r. Okay? It's going to be 2 minus y. Now, if the line of revolution was this side, here, say maybe y equals to minus 1, r was then going to be what? It was going to be y minus minus 1. So you'll get that r is basically y plus 1. When we are here, r is y on the x-axis, r is y. When we shift to be here, it's y minus something or that thing, you know. Y still has to be there, but it's not only y. So if we think about it, it's going to be 2 minus y. If you are using this one, it's going to be y minus minus 1. So those are the things that you have to understand about r. Then obviously your f of y in this case is just going to be 2y squared. Then yeah, it goes without question that you need to understand that you'll be integrating from 0 to 1, I mean. So those are the things that I feel like you should be able to comprehend. And whenever you have a function, a curve like this one and that one, be careful on your f of y now. Okay, if we were to draw this curve, what was it gonna look like? This curve, x equals to y squared plus 1. It's a parabola shifted 1 unit to the right. So say 1 is somewhere here. Then we'll have a parabola like this. Or let me redraw the thing. This one is the same as that one, okay? So we'll just have it like that. And the other one, this thing is glitching a lot. And the other one, x equals to y squared plus 1. It's a parabola that is shifted 1 unit. So we'll have something like that. They will intersect obviously at some point. Say maybe they intersect there. I didn't draw it to scale, but say maybe they intersect here and there. So the region that is enclosed is gonna be this one. That is the region. So what I meant by saying be careful of your f. Your f will be which function? It will be this one minus that one. Wait, where are we even revolving to start with? So we are revolving about the line y equals to minus 2, right? So if we are revolving about the line y equals to minus 2, where is this line? somewhere at the bottom there. This is our axis of revolution. Then what is going to be R? R, we are revolving around the vertical line, I mean a horizontal line, so R is just going to be 1. No, it's shifted, ne? So it's going to be what? Y plus 2. Y minus minus 2, so it's y plus 2. What about F? F will be what? This function minus that one. So this function is y squared plus 1. Then minus 2y squared. And basically you get minus y squared plus 1. So your f will be minus y squared plus 1. Then to find the bounds, since you are going to integrate in terms of variable y, you need to know what is going to be the value there and what is going to be the value there. Obviously, you can find that from the intersection of those two graphs. Okay, so if you equate them, you can solve and find out what is it going to be. And really, if you think about it, it will be 2y squared equals to y squared minus 1. Then we get that basically, if we take this guy to the other side, we'll have, I said minus 1, it's plus 1. Then we'll get that y. If we take this to that side, we have y squared equals to 1. So we get that y equals to plus minus 1. So here we have 1 and there we have minus 1. So we'll integrate from minus 1 to 1 times the integral from minus 1 to 1, 2 pi of your r, y plus 2 times your f minus y squared plus 1 dy. So that is the analysis for quotient deity. Yeah, I think I've said all the necessary stuff. Any questions from your end?